we're going to work on 3C now, and they want you to find the holes and any asymptotes of the graph. So we need to find the horizontal asymptote, maybe, vertical asymptote, maybe, and holes in the graph, maybe. Well, if you've missed the last couple days physically or mentally, here's how you find those three pieces of the graph, all right? For the horizontal asymptotes, that's where you check to see if it's top-heavy, bottom-heavy, or balanced. So for C, x squared plus x plus 1 over x squared minus 4, is that top-heavy, bottom-heavy, or balanced? It's balanced. So you look at the numbers in front of x squared, the highest degree, and you divide them. What's 1 divided by 1? 1. So the horizontal asymptote is at y equals 1. Now you can totally forget about top-heavy, bottom-heavy, balanced. Doesn't come into play for the rest of the problem. All right? For the vertical asymptote and the hole, into. So for this, you want to look at factors that don't cancel, particularly on the bottom. You're really worried about the bottom for both of these, all right? Look at the denominator. We're worried about the bottom equaling what magical number? 0. 0's the bad guy here. 0's the one that's going to give you these vertical asymptotes and holes in the graph. So to do either one of these, vertical asymptote and holes, you need to be able to factor. Can you factor the numerator? X squared plus x plus 1. I need two numbers that multiply to positive 1 and add up to positive 1. Plus 1 adds up to 2, right? So they don't work. So it appears as though the numerator is not factorable. If you were really a fancy math student, you might take the A, B, and C, 1, 1, and 1, and do this with them. What was this called? The quadratic formula's certain part. Yes, sir, the discriminant. And if that discriminant comes out to be negative, it's not factorable. What is 1 squared minus 4 times 1 times 1? Negative 3. And if the discriminant is negative, it's not factorable. So the numerator, I'm sorry to say, we're going to have to leave it alone at x squared plus x plus 1. And if the numerator doesn't factor, nothing's going to cancel with anything in the bottom. So what does that eliminate from consideration if nothing can cancel? Holes. This graph will not have any holes in it. There might be a vertical asymptote. That's going to occur if the bottom can factor. Can it? Does the bottom factor? It's the difference of squares again. What times itself is x squared? X times x. What times itself is 4? 2. If it's the difference, you're going to need a plus and a minus. So, are there matching x plus 2's on the bottom and top? So x plus 2 can't cancel with anything. Does x minus 2 match anything on top? No. So nothing can cancel. So there are no holes in the function. However, are there any factors on the bottom that don't cancel out with anything? Yes. Are there numbers that you could plug in for x that would cause 0 to show up on the bottom? Where are they? What are the two x values? Negative 2 would cause a problem, and 2 would cause a problem. That means the graph has asymptotes at both of those values. All right? So it likely has 3 parts to it. One part that's like a hyperbola on the right side, maybe doing something like this. I don't know the exact shape. I haven't looked at it lately. One that might be doing something like this. And then another part that might be a parabola. We're going to look at some weird functions later today. All right? You could always take a peek at the graph and just see what it looks like. Take a glimpse.